So this is 5-1. It's a one-day lesson on the introduction to probability. So the definition of probability. This is not an AP topic, but it annoys me that people don't understand it. Probability, by definition, God bless you, success over total. Odds is not interchanged with probability. Odds, if it says there's odds for and odds against. Odds against is the default. Odds against is fair to success. They don't mean the same thing. So I saw this week, ESPN has the Eagles having a 60% chance to beat the Giants. Is that logical?
No.
Yeah, because the Eagles are home. The Giants only have one win. The Eagles only have one win. But they got a home game, so yes. So the probability that the Eagles win is 3/5 plus the square root of 60. It's 6/10, 60% chance of winning. But what's happening? Failure isn't in here. See, probability doesn't include failure, and odds doesn't include total. So if I want the odds that the Eagles win, that would be fair to success, 4-6. And you can reduce it just like you reduce a fraction. When you think about it, if you watch like you watch a Triple Crown horse race, and they show the odds, they're showing the odds before the race starts. If this number is smaller than that, then the horse is more than a 50% chance likelihood of winning the race, which is very rare. Okay? But this is failure to success. Next thing, the law of large numbers. So you got this coin toss. You want to do this simulation to see if this coin is fair. And if you notice this, it's the same coin. This is the same simulation. This is in your book. Except to the left, there's 10 trials. To the right, there's 500. So what's happening? The first, and this is a proportion of heads. So what happened? First time they flipped the coin, what happened? Heads or tails? Well, first time they flipped it, what'd you get? Heads. You're up here. Second time they flipped it, what'd you get? Tails. It went down here, 1 for 2. Third flip, heads. Fourth flip, tails. Fifth flip, tails. Yes? But then if they stretch it out, this graph is this graph. This has just been squeezed. And you see, what happened was, in the first 10 trials, we expected to get heads 5 times. That's the expected outcome. In the simulation, you got heads 3 times. That's fine. In 500 tosses of the coin, you expect to get 250 heads. This simulation looks very close to 250. It might be a little higher. But. So what's happening? As the sample size gets larger, you're going to go to the expected outcome. So the point is, at the beginning of the season, like what's Bryce Harper? Bryce Harper is probably a 260 lifetime hit, a little better than 1 out of 4. If Bryce Harper gets up and makes 3 outs, he's not guaranteed to get hit the 4th time at bat. He's got a 26% chance of getting a hit. Okay? You still wouldn't expect him to get a hit on that 4th at bat, even though that would raise him up to his expected outcome. large numbers, if you go over the whole season, he's getting 26 hits for every 100 bats. Not just one game. Okay? So here is the simulation. And this is what's on page 306 and 307. And people need practice with simulation. So you're going to follow this before you do your own simulation. And you've got, ready? 95 kids, 95 seniors in this scenario. And 28 of them are in AP stat. So we want to do this simulation. So we're going to number the children, 0, 1 through 95. We need 2 digits. Double-digit kids. It is, it wouldn't be wrong to use 3 digits. You wouldn't get the same answer here, but in the long run you would. In 3 digits, you'd have 001 through 095, but then you'd be ignoring 096 through 000. It'd be just, you have too many numbers to ignore. It wouldn't be efficient. So, success is 1 to 28. Those are the kids in AP Stat. Failure, 29 to 95. They're seniors, not in AP Stat. These numbers are no good to us. 96 through 100, and 100 is represented by 00. There are no children represented by those numbers. So we do the simulation. We're using the table that's on page 306. They're giving you this row. Get used to it. You would see this on an assessment where they give you the row. Why? Because then everybody's answer is going to be the same. Makes it easier to grade. The columns don't mean anything. That's just so you can read the numbers without losing your place. So the first pair of numbers is 70. 70 is in this set. Not an AP kid. The second pair of numbers is 70 again. Can you see this in the book? So we ignore it because this is without replacement. The third set of 2-digit numbers is 84. So the first trial, no AP kids got the parking pass. And we're going to continue from there. You don't start over again. You start where you left off is 84. Second trial, right? We're stopping when we get 2 kids to get a parking pass. First number is 10. I need you to do this. I need you to look in the book and make sure where you can see I got that 10. Because I'm counting these 2, 4, 6. So that 8 is the end of the first grouping, and 4 is the first number in the second column. Okay? No. Okay, fine. 4 is the first number. So you pick up with the second and third numbers, which is a 10. That child's an AP stat. Good job. The next pair of numbers is 98. 98 is the no good numbers. There's nobody there to represent them. Assign that to. You ignore it. 55, non-AP child. So in the second simulation, you've got 1 AP child. Third simulation, but you stop when you get 2 kids. First pair of digits is 18. Yes. Second pair of digits 19. Yes. So in 3 trials, 3 simulations, like you're an AP stat, you're trying to defend this outcome to the student body who says, no, you fixed it. This is fixed because the AP stat kids both got a parking pass. This is all great. Oh, here's a simulation explain. Oh, I don't want to hear about. You don't want to hear it because you don't understand it. It's not unlikely. So in 3 trials, 1 out of 3 of them resulted in 2 AP Stat kids getting the parking pass. And something that happens 1 out of 3 times by chance alone is not statistically unlikely. That was just 3 trials, yes, with the law of large numbers. So if we go here and look at this, you get 2 AP students in one of the trials. It's not 1/3, it's really this. That the one kid's an AP, 2890 pence. Yes. That the second kid is, because it's without replacement, would be 27 kids left in AP and 94 kids left altogether. And that product is about 8.5%. That's still not statistically unlikely. Something has to occur less than 5% of the time by chance alone to be considered statistically unlikely. This scenario right here that they drew for you, they made it up, we would expect to happen 8.5% of the time by chance alone. It can't happen 8.5% of the time when you only did 3 simulations. That was just to give you an idea. Okay? So, we're going to pause this. You're going to 2 questions. 5 and 11. Number 5. Number 5 is a picture. Ready? What happened the first time this guy took a shot? Make or miss? Missed it. Why? Because it was never up here at 100%. Didn't make his first shot. Yes? He missed the first shot and made the second one. That put him up to 50%. Third shot, missed it, made it. Yes? You can see what's going on here. And then after 1,000 shots, he's settling into about a 30% shooter. Is that good, Cole? It's all right for high school. You shoot 30% in the NBA, you'll be looking for a job. Okay? 30% in the. This is where this person's going. After 2 shots are 50%. Go, this guy's a 50% shooter. This girl's a 50% shooter. No, they're not. The sample size is too small. The simulation. All right, I'll look. Where's that? 7?
70.
Wow, how about that? This is a okay. So, first class, 0 to 12. Coach, 13 to 76. 76 passes altogether, 12 are in first class. You ignore 77 to 100 and the repeats, which I did ignore. Apparently, Laughlin found that there's a mistake here at the end. She's fine. We don't give fist bumps for finding my mistakes. Okay, yeah. Ready? The first passenger, 71, fits in here, coach. Coach, 99, too high. There is no passenger 99. Ready? 84, same thing. Coach, the first passenger gets picked is 7. First class passenger. 71 already came up. They already coached. We're ignoring repeats. We go over here. 70 is coach. I should have ignored this because that's a repeat. So then what's the next pair after 7? Do people keep going? 52? So the next one's 52. And this should just say 52 here, which is coach. We good? This one should say repeat. So the probability, the big picture probability theoretically is 12 out of 76, which is a little less than 16%. In the simulation, 10%. Because you would keep going one more time to see how many first-class passes you would get, and it would take one of them out of 10. Okay? That's random variability, 13, 10%, 15%, or 60%. Then I did this. This is wrong. I didn't realize it until this morning. So I'm saying theory all over the target. Right? Theory is 64 to 76 people are in coach. So I said, what's the probability of getting that 10 times in a row? Yes? And I got this, 18%. And what happened? The actual probability is between this theory and the simulation. But what's wrong with this? Let's hold the graph line. I got it straight. What's wrong with it is this is with replacement. Because it's saying it's only 64 to 76, but it's not. It's 64 out of 76 times 63 out of 75, dot, dot, dot. Yes? You have to keep going, yeah. Right? So, that is 5-1, which is not on the assessment, okay? So I will edit the PDF in regard to that repeat that Laughlin found. I'm fine with that other one being on there because now, if you are at home, you are going to AP Classroom, do the exit ticket. If you need, we're not done. People are home. If you need help regarding the test, which you're taking on Friday, because you're going to be here on Thursday, then you have the office hour option tomorrow. This, what we did today, is not on the assessment. So you're dismissed. You go to AP Classroom. Whoa. Let's stop.